So we're going to finish our project from the loops section. I think that it was a bit complex project. You probably got you confused, so I will try, as you learned in the function section. Functions can help reduce the complexity of your code, make it more modular. So this is what I'm going to try and do with this project. Now, first, I will extract the calculation in another file. So I'm going to create a new file, function. This function file will return one value or vector depending on what we are calculating. So x equals calculate 1D motion. This will be the name of the function. It's going to take some arguments. We will see now what we're going to need and we will end. Now let's take our equations from here. This is the equation that this function is going to calculate, and we need x equals x0 plus vx times t times possibly some angle plus the acceleration, so xa times t element by element squaring divided by 2. Now let's add another set of brackets here. Let's add another set of brackets. So this is how we are going to calculate our x values. We're going to use the same function for the y values as well, but we're simply going to use x. It doesn't really matter what it is. So the inputs that we need for that function are x0 v of x, or rather xv. We also need the time vector, we also need the angle and the xa. So x0, xv, xa, angle and time. And suppress the output, save it. So this is calculate 1D motion. Now we can go ahead and remove all of these and only use the function. So x of I, the whole row of I, will be calculate one-dimensional motion, and we need to give it some arguments. So we're going to give it, let's see what it requires. It asks for x0, xv, or in this case xv of I, the current xv, xa, angle, and the current time vector. Just like that. We're going to use the same function for the y. So y, the whole current row of y, calculate 1D motion, y of 0, yv of I, then y of a, angle, and t of the current t vector. This is not actually angle, this is the x angle, and this is the y angle. Now, if we run this project now, it should be working. And it is working. What changed in this project? The thing that changed is that here we are no longer using an equation, we are using a function. So if you give this project to someone else and he reads this line of code, he will see that you're calculating the one-dimensional motion by using these arguments, these inputs. That person does not need to know the equation. You don't need to know what is the equation behind this calculation. This is the beautiful thing about functions. So if you want to calculate a motion, you simply have to use the function and give it what it requires. You need not bother yourself with the actual implementation of this. So we didn't reduce the amount of code, but we certainly reduced the complexity. Now let's do the same thing for the non-zero root. We can create a new function which will calculate our non-zero root. So it will be function nzr is going to return a non-zero root, and it's going to take in some arguments. Let's see what are these arguments. So let's simply copy and paste this into the function. And what do we have to change about it? Let's also copy and paste the equation that we're going to use. So find roots of something. Alright, first, we no longer have any indexes here. let's replace the x's with the y's with x's. So x and x and x, just because x is by default, not because we are calculating the x root. And here we're going to return NZR like this. So we are calculating the roots and we are returning the non-zero root. Now, what are the inputs that we need? We need x0, we need xv, and we need xa, and we need the angle. But here we're no longer going to use the sine of angle because we are calculating whether it is sine or cosine in the other file. So here we are only going to use angle. Now, if we go back here, instead of using y roots and non-zero roots, we are going to delete this and delete this. This will be non-zero y root. I have to change the name because I used the same name for the function file. And this will now be non-zero y root is equal to non-zero root. So here we have to give it the y of 0, we have to give it the current velocity, we have to give it the acceleration, it's 0, but nevertheless we need to give it, and the angle. Let's confirm, yes, 0 VA angle. Now let's see if it's still working. No, it's not working. Now what changed? Not enough input arguments. Okay, we have to use the non-zero y root here. Let's try again. So everything is still working. Again, we reduced the complexity of the code. Here when we use this function, it requires these arguments and we know that it will return the non-zero root. We are not concerned about how it calculates it, we only know what it does and what it requires to do. And finally, we're going to create one additional file which will take care of everything here about the plot setup and customizations. So let's create it. This will be function setup plot. This function will not return anything, it's not going to return any values, it's only going to perform some actions and it will require some inputs. The inputs that this function is going to require are the x and y. This is obvious, x and y, because we're working with x and y values. And I am simply going to copy this here. And I'm going to delete it from here now. I'm also going to copy and paste the rest of the things. The limits, there we have it. This is a setup plot. It needs x, y, and it also needs, so it actually doesn't require x and y, it actually requires x min, y min, x max, the vectors that we generated. So x min, x max, this will be y min and y max. So let's go back in our file here and let's delete this, and here we're going to use setup plot. It's going to require our minimum and maximum vectors. So x min, x max, y min, y max. Let's see if everything is still working. There we have it, it's still working, and we removed a big chunk of code from our file. Now, if you want to also extract the recalculation of the limits, you can do it, but it's going to be a bit tricky. It's going to be a bit tricky because you will still require to recalculate them, and yeah, actually, why don't you do this for homework? Try and also extract the limits in another function file so that you can reduce the complexity of your code even more. So here, let's make this a section, pre-allocation of the x and y. This is generating the time vectors. This is plot setup and customizations. And this is the calculation and visualization and plotting. Now, let's minimize this. And you can see that our file has a couple of sections. Everything is now a bit more organized. So there you have it. We created 3 function files in 10 minutes, and this, with the exclusion of the limits that we're calculating here with, is now a much more readable file.